Again. Alright, we're back. Hello everyone, it's September 7th. My wife is no longer dying because we find a way to cool her down. Oh, it's like this is not my chair. I was like, where's my socks? It's behind you. I think you're... Okay. Alright, let's do it. Yeah, it's so hot. For a few days. Wow. We done this not that long time ago. Okay, we have to redo it. When was the last time we done it? Oh, it's been a year. Huh. Interesting, it's been a year. First time we do it, 2021, on my birthday, no less. Second time we've done it is September 6th. Oh, today's September the 7th. That's exactly 1 year. All right, split linked list in parts. What do we have here? Given head, split it into k consecutive linked list parts. The length of each part should be as equal as possible. No two parts should have a size differing by more than one. This may lead to some parts being null. Some parts being null. The parts should be in the order of occurrences in the input list, and parts occurring earlier should always have a size greater than or equal plus you to parts occurring later. Return an array of k parts. Or basically you count the whole thing. I see. You count the whole thing, right? And you do division by k. Then you know how many each one will have. Then the remainder will be, starting from the beginning, you will just add 1, add 1, add 1. So for example, k equals 5, the length is 3. 3 divided by 5 is 0, which means the default state is 0. And 3 mod 5 is 3. So for the first 3, we'll add 1, just like this. So we return as a list node, okay? Yeah, we can do it. Should be done pretty fast. Shall be done pretty fast. If we finish this fast, I have something I want to do, which is yesterday. Yesterday, we have the KMP. The KMP, we didn't do it because, you know, it's just hard. KMP is always hard. And kind of didn't do the KMP. So we're going to do it today. We will do the KMP today, but we finish this fast. All right, so first things first, we need to count, all right? We need to count how many there are. How do we count? We need to have a node equal to head. We say while node is not equal to null, n++, node equal node on next, right? So we count the first one, move next, we count the next one up into the last, okay? And then we'll say int each shall equal to n divided by k. Int remaining is n mod k. All right. Then we will say list node rest shall equal to new list node. We'll have k. And then for k of them, for int I equal to 0, I smaller than ki plus plus. Okay, for each one, we will do each number, right? So what we're gonna say is, all right, we'll have a node. We need a node, so we put a node out. It's gonna be head, and then what we're gonna have is what do we have? Each, I have each, so we have count shall equal to each, maybe not, maybe we can do for int j equal, actually, yeah, it's fine, j equals 0, j smaller than each plus something, and j plus plus, okay? And this is going to be remaining is larger than 0. If it is, we're gonna plus 1, otherwise we'll plus 0. Okay, and then we're gonna move j times forward, right? Move j times forward. Ooh, hold a second. I have a node, right? So once we start, we'll put res I shall equal to node, okay? And then we're gonna say list node current equal to node. And then we'll use this to move the current forward, right? Once we move the current forward, and then we reassign, actually here we'll reassign, say node equal to current. That's we move it forward. Okay, how do we move it forward? We say current equal to current dot next, right? So we set it, and then we move forward. We set it, so maybe we should not do, let's say if we have 3 nodes, we have the first node, right? And then we only moved 1, 2, so we move 1 time, move 2 times, move 3 times. Yeah, we do have to move 3 times. Yeah. So we do that, and then current equal to current dot next if current is not equal to null, right? We'll do this. Move forward, we try another time, move forward, we try another time, move forward. Once we finish, current will be pointing to the next one. So node equals to that. Coming back to the next one, we set it, we do it again, and then we will return result. Duplicate local. Oh, I already set node. Oh, okay. So we'll just reset it. Okay, let's try it. That is not right. That is interesting. Did you forget something? I think I did forget something. For one, the remainder has not decreased. Okay, several things is wrong. Yeah, several things is wrong. So first thing is every time I do this, we have to this is minus, and then once we set, we have to end this linked list, right? Ooh. How do we end the linked list? Okay, I'll change my strategy. Int count. I don't think I have a count. Shall equal to each plus remainder is larger than 0, 1, otherwise 0, right? So that's count. While count is larger than 1, and current is not equal to null, current equal to current on next, right? And then what we're gonna say is if current is not equal to null. Okay, So we go to the end. So we have one more count, right? One more count. So I need to move forward, right? So now we actually pointed to the last one. So I need to move forward. So what I need a temp. Okay, I need a temp. So I say list node temp shall equal to current.next. Current.next shall equal to no. And then temp, and then current equal to temp. And then remainder, and then we say the node is equal to current, and then we'll assign it for the next round. Okay, so this is kind of a new one. Let's take a look if this make any sense. All right, this one is right. This one is still not right. Why? Oh, because you forgot to do. Yeah, my bad. I forgot to do count minus. That's why. Yep. I shall do. All right, let's see if we can make this one a bit easier. I believe we can. So we have the node, and now we go. Why do we need this current? Why do we need a current? I don't think we need current. Let's not do current. Right, and then we just say node is now equal to no. Yeah, you can move node forward. Because this is just a address. So we set address here, and then we change it. Right, that's fine. Don't need this. $7.25. The length of each linked list in the result. Now each split linked list is n divided by k plus 1. The base length, okay? If n divided by k has remainder, they will be evenly split among the first few split linked list. Okay. Let's see if we can get it one shot. We cannot. Oh, I don't know why. I already... Did you forget something? Yeah, I did forget something. Oh, that was... Because I fixed it. But then, maybe I forgot. Yeah, I think I...
There's only one option for Catholic church around.
Yeah, I remember.
Can't believe it. Really nothing.
There we go. That was just oversight. That was absolutely an oversight. Because I already corrected it. But I guess I just forgot to copy and paste. And you can use a scooter. Right? That's a good use of scooter. And you can bring the scooter in. You don't even have to have the scooter out. That was the last time I have, take, length, big, small. Node equal to take. I have a count. Yep. This is actually a good design, I would say. It's better design than this. This is kind of, we put everything together. I mean, it works. It works, right? It works. It doesn't matter. But we'll call this a day. All right, so we have KMP. All right, let's do KMP. Yeah, we know we need to do a prefix table. Basically, in KMP, what we're trying to say is, if I remember right, we have this AB, CAB. What we want is, so we have a prefix suffix table, right? A prefix suffix table. What we want to say is, what is the longest length of prefix that matches the current suffix? Like this one will be 0. This is also 0. This is 1, right? Because we match this. And this will be 2 because, matching the length. Yeah, this match 2. This will be 0. This will be 1 again. This will be 2, and this will be 1. I think that is the prefix suffix table, if I'm correct. So once I start matching anything, we're matching here. Right? If we have a mismatch, I will check this. We know that we will have 2 match. Right? Whatever we're matching into this, we have 2 match. So the next time we match, we'll match starting from here, right? Because we know the prefix will match 2 already. The prefix suffix table. How do I calculate this? How do I calculate this? So if a prefix is 0, that means there's no match. So I always check the front, right? And the next one, the prefix is a match. So I check the length, I check this. If it's a match, we just add it to it. But if it's not a match, then I again match the front. I think this is the, okay, we're probably in the KMP again. Just see if we got it right. Did they say what LPS stands for? They didn't even say what LPS stands for. Seriously? Are you kidding me? You have LPS, but you didn't specify what LPS stands for. KML, LPS. Not KML, KMP. KML is not the same. Longest proper prefix, that's what's called. The longest proper prefix. Okay, longest proper prefix. Let's see how LPS, longest proper prefix of pattern, which is also a suffix of pattern. Yes, right? So are we doing this on a pattern or on the original? I think we're doing this on the original, right? No, it says text and a pattern. We're doing it on a pattern. Huh? We do it on the pattern. So if we match, and now we have a mismatch, then we check. Yeah, it's the same thing. It's the same thing. Yeah, we do it on pattern, okay? So we say compute LPS given a pattern, right? And the length of the previous longest suffix. This is true. Okay. If the pattern this is equal to pattern.char at length, pattern at current I is equal to pattern.char at length. Length is the previous longest, right? If this is equal to pattern.char at the previous length, then length plus plus LPS I equals to length I plus plus. That's correct. If they're not, so basically just saying if the new one, right, I is the new one, is equal, if we can extend, right, if we can extend. If we cannot extend, then what we need to do is to check the beginning. If length is not 0, if length is not 0, okay. If length is 0, yes, that's correct. Okay, this is the key. I didn't realize this. If length is not equal to 0, that means we have some pattern previously. Then the current length shall become, the current length shall become LPS length minus 1. LPS len minus 1. Len is the maximum prefix, right? So maximum prefix is here. And the current one is not equal to pattern. So these two are not equal. Okay, so these two are not equal. So now you're saying our length shall be len minus 1. So len minus 1 will be this one, right? But what do you assign to len I? Hold on. LPS len minus 1. LPS len minus 1 is the maximum length of that one. Which is the longest matching at this one. So what's the longest one? Why do you do L minus 1? Hold on, I still don't understand this one. LPS is a length, right? It's the length. So len minus 1. Len is so what we're saying, okay, what we're saying is we have a very long matching, okay, and then here we have a mismatch. So what we do is we're trying to, because we're saying at this position we have this length, right? We have this length. We're doing the LPS Yeah, but anyway, just they're not matching. We cannot extend the length, right? So the match has to be smaller, right? So what we're saying is, tell me what is the length. What is the length of the letter ending, right? Ending at this position, len minus 1, which is the last, right? Which is the last, which is exactly the one to the left of the current letter, right? I just need to know.
I'll fix it.
I just need to know the length, right? The length. Yeah, ending I hear what is the length. So current length is long, but then we have a mismatch. So when you reduce the length, right? Reduce the length to that one, right? Because current length is this much. Current length is this much. So if we do the length minus 1, LPS line minus 1 is that. Yes, it'll make, basically if we say blah 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 blah, and then this is the start, and then currently we have blah 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 as well, and then this is the next one, right? This is the next one we're trying to match. Yeah, so this is len. So this is pattern len. Okay, this is pattern I. What we're saying is if these two do not match, okay, and then we need to reduce the length to what the length is for this position, because this is the same as this position. So the length of this position is not pattern, LPS len minus 1. This is the LPS for this position, which is the LPS for this position, because this part and this part are exactly the same. So this value will tell you how much, right, how much to the front that this one is matching, right? And then you're gonna do it again. Try to do pattern I matching, because you will set len equal to this. So we actually compare, if it's 3, right? Now we're trying to compare this to this. And it makes sense now, right? It makes sense now. Okay, so this one makes sense to me. And then when we actually do the matching, so yeah, essentially for this problem, we can because I have the linked list, right? I have the linked list. I can do the KLM on the linked list. Yeah, I can do the LPS on the, basically this I think is probably pretty much the LPS, right? Pretty much the LPS. Search in tree. They're probably a little bit more, but technically one way we can do is just to do the KMP directly. We'll get a pattern out. We'll run this to get LPS, and then each time we hit the end, we'll do LPS. Each time we hit the end, we'll do LPS. Okay, so I just need to understand how to do the KMP search. We'll compute this. That's fine. N is the pattern length. N is the text length. M is the pattern length. So N minus I, which is the remaining, if it's larger equal to M minus J. I think J is the index on pattern. So this means if we have enough left. Now we say if they're the same, we move forward. Yes, if it's the same, move forward. If j is equal to m. And in this case, if j is equal to m, which means we have reached the end, right? And in this case, we'll add I minus j plus 1. This is the position, right? We add the position and we'll reset the j position. We'll reset the j position to LPS j minus 1. What's that? So this is when j matches, right? When j matches, j is equal to m. No, 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 no. Oh, okay. All right, I'm back, and yeah, let's just finish understanding this and then now implement it. So when it's the same, that means we finish the pattern and everything matches. So we go LSP j minus 1, LPS, LPS j minus 1. This tells me what is the matching, the prefix matching so far. So I move that, so this is where the j is supposed to be. Yes. Else, if j is not equal to m, so we haven't matched yet, depending on whether we have a match or not, and we say I is smaller than n. Yeah, we're checking, right? We are checking, basically just saying if they're not equal. I feel like Yeah, this is weird because pattern, if I can do pattern.char at j, then j will not be equal to m. Right? It's I feel this shall go first. You should check this one first. Right? You should check this one first. Yeah, you should check. Oh, it makes sense. It's because j plus plus. If j plus plus, then it become m, then you do it. Okay, that makes sense. And if not, j is not equal to m, then if I is smaller than n, so we haven't finished I yet, but if I is larger than n, then we're basically done. Right, we're basically done. So I is smaller than n, and then we say these two are not the same. Okay. Then we say if j is not equal to 0, so we have a mismatch. J is not equal, so j shall equal to LPS the previous one, because yeah, so this is a mismatch, so we need to know where my j is supposed to be. So LPS j minus 1, yes, it's the same as this one, right? Because j minus 1 is the previous one, so I need to know the LPS of the previous one, so I know where I put my j if j is not equal to 0. But if j is equal to 0, that just means we have a mismatch. So j is at the beginning, so we have nothing to go back on, because this will be negative. So we just move I forward. Yeah, it makes sense, right? We went through KMP again, makes sense. So what I'm gonna do next time on this is not using this, because I think they have something special. So what I'm gonna do is exact same as this, which is to not really solve, not like this. It's the previous one. I'll get a pattern out, I'll get LPS, and then I'll write an algorithm which will do the KMP between two array list of numbers. And then when we hit the end, I just call it. Right? I just call it. So instead of m times n, it's still going to be m plus n, because it's, it will be much faster when we do it. All right, so this will be something we do next time. I'll see you guys next time, tomorrow.